Alright, here we go with iChem lesson 27 on Solution Stoichiometry. You'll need a periodic table to follow along with this, along with your viewing guide. So, this is not new news that dimensional analysis uses ratios to cancel units and to calculate answers, to do unit conversions. So we've had a bunch of different ratios already. We've had molar mass. Those numbers come from the periodic table, and the ratio is grams per mole. We have mole ratio from balanced equations, and that's like moles of something over moles of something else, where the number is the coefficient in the balanced equation. We have mole to energy ratio, we just did in the last unit, which you have kilojoules per mole. And we have molar volume and Avogadro's number, and all of those conversions as well. We're going to add one more. And this is a moles of solute to liter of solution ratio, which we already know to be molarity. So here's some molarity mole to liter ratio examples. If I have a 1.5 molar solution of hydrochloric acid, remember molar is moles per liter. So I can write this as 1.5 moles per liter. Ratios, remember we can do 1.5 moles per liter, per 1 liter. This ratio can also be written, means the same thing as 1 liter over 1.5 moles. Okay. Either way, we can use this 1.5 molar, remembering that capital M molar means moles per liter, and write it as a ratio. Moles over liters or liters over mole. We can set this up in stoichiometry. Here we have 0.200 molar potassium phosphate. So I have 0.200 moles per liter, and I can write this as 0.200 moles per 1 liter, or 1 liter per 2.00 moles. Now it depends on our given in our problem statement whether we want to use the equation or the ratio in this form or in this form. So let's look at the first example. What volume of 1.5 molar hydrochloric acid is needed to react with 21.5 grams of NaOH? Remember, stoichiometry problems all have to do with a reaction. So step number 1 is to write a balanced equation. We need that to do a reaction. So now I have hydrochloric acid, that should have said HCl, plus NaOH, and this is an acid-base reaction. We're going to deal with those next week. Reacts to form double replacement, so NaCl, these two together, and H and OH together, and water. Acid plus base gives us salt and water. Okay, so, and this is already balanced. So now I want to know what volume of 1.5 molar hydrochloric acid is needed to react with 21.5 grams of NaOH. So this is how much I know is reacting. So I'm going to start with this. 21.5 grams of NaOH. I need first to convert this to moles. In the end, I'm trying to find liters of hydrochloric acid. Okay, so grams to moles always first to be able to use any sort of stoichiometry. The molar mass of sodium hydroxide, sodium is 22.99 plus 1.01 for one hydrogen plus 16 for oxygen. The molar mass of sodium hydroxide is 40 grams per 1 mole. Okay, so now I have moles of sodium hydroxide. I need to find something about hydrochloric acid. So on the top I'm going to put moles of HCl. This from the balanced equation, so 1 and 1. This is where it gets different. Now I have moles of hydrochloric acid, and what I want is liters. I can't use 22.4 here. That only applies to gases. This is a liquid. This is a solution. So I come here. I have 1.5 moles per 1 liter. This is my ratio. So 1.5 moles per 1 liter. For volume of a liquid, the conversion is your molarity. So I do 21.5 divided by 40 divided by 1.5. And I get 0.36 liters of hydrochloric acid. Okay, so the only thing that's new here is this last part, using molarity as a conversion factor. Everything else started the same, from grams to moles, moles of given to moles of unknown, and then from moles to liters using our molarity. Let's do another one. Now I want to know what's the molarity of a solution of H2S, or hydrosulfuric acid, if 48.5 milliliters are required to titrate. Titrate's another word for react. 35.6 milliliters of 0.35 molar iron hydroxide. Okay, so this is my given. I know that this is reacting, and I want to know something about this one. So I'm going to start with 35.6 milliliters. But remember, this is moles per liter, so I want this in liters. So it's 0.0356 liters of iron hydroxide. I have liters. First, to use a balanced equation, I need moles. This now comes from my molarity, moles per liter. 0.35 moles per 1 liter. To be able to go any further, I need a balanced equation. Iron hydroxide to moles of H2S. This needs to come from a balanced equation, so let me go ahead and write one. H2S plus FeOH 2 yields. Okay, so iron has a 2 charge here, I know that, so Fe 2 plus, and sulfur always has a 2 minus, so this is going to be FeS and H2O. Now here I have 2 hydrogens and 2 hydroxides, so I need 2 waters. The coefficients of H2S and iron hydroxide, the 2 outside the parentheses, are 1 and 1. Alright, so now I have moles of H2S. That's where I'm going to stop this time, because I have moles and I have volume. Then I can use my definition to find molarity. So 0.0356 times 1 divided by, so times 0.35 times 1 divided by 1 gives me 0.012 moles. Now let's remember our definition for molarity. If I'm trying to find molarity, I need moles per liter. I have moles right here. I can get liters from here, and I just need to divide it. So 0.012 moles divided by 0.0485 liters gives me 0.0212 divided by 0.0485 gives me 0.25, and then the units are capital M molar. Let's do one more. Actually, let's just stop here, and I will do this example in class with you tomorrow. We'll start with this. Okay, so if you need to go back and check either of the other two examples, go ahead. All we did was add this, which is molarity, as a conversion factor. Now we have a way to convert from liters of a solution to moles of a solution. So adding to our toolkit of conversion factors. Make sure you do the Google form, and see you tomorrow.